Shall we wait others or shall we start now? What do you have to?
Hello. Hello.
Yeah. Hello.
Yes, I think we should start because I think only one participant is there.
Yeah. Yes.
The other three is on. Or should we wait for another 4 minutes?
Yeah. I think we'll wait because normally some more students used to come, right?
Yes, yes.
Hello, ma'am.
Yes.
Ma'am, regarding assignment 2 and 3, they said they will upgrade assignment scores, but they haven't.
What about that?
Regarding assignment 2 and assignment 3, there are some questions which was taken out of grading. So our total score should be updated.
Can you type it? Like I cannot because noise. I cannot hear clearly.
Okay.
Hello, Sanjay.
Yes, sir.
What kind of doubt you have in assignments?
In assignment 2 and assignment 3, there are some questions that was graded answered wrong. So we informed it in the discussion forum. Then we
Okay.
got a reply that those questions will be taken out from the grading and the
Yes.
rest will be graded.
Yes.
Uh, Now our score is not changed
Oh, that
after
will
taking.
change. That will change. Actually, NPTEL is a big thing, so crowd is very high there. So they will change it. I had a talk with NPTEL team who is handling this particular course. It will be updated.
Yes, sir. Thank you, sir.
Okay. Let us start. That will be better, I think. Okay. So today, what I thought like, we'll discuss uh, the questions which I take from week three assignments. Okay, earlier week three assignment, similar kind of question, not the same question. But when I check it week three assignment, it's more discussed with Carnot engine and all. So I thought we'll also discuss today heat engines and Carnot engine cycles. So that's why first question is related to that. Um, a 15% efficient heat engine loses 1000 joule of heat to the surrounding per engine cycle. How much work does this engine do every cycle? Okay, So for doing that, you have to know what will be the heat engine efficiency and all. So in first step, what we have to calculate, like we have to identify the value of efficiency E. Okay, I'm taking efficiency E here, and the heat transferred into the engine. That we can represent it as QH. Okay, and heat transfer out of the engine. That QC. And from the question it's given that E is how much? 15 percentage, and QC is 1000 joule. Okay, so these are the data, like information we got from the question. Now in step 2, what we'll do, we need to calculate QH. So QH we have to find it. Now if you want to calculate QH, what you have to do, QH will be QC divided by 1 minus E. That will be E divided by 100. That in percentage. Okay. Now just we have to give the values here. 1000 divided by 1 minus 15 divided by 100. So you will get the value of QH. So try to solve this. It's very easy and get it the value of QH here. So here you will get the answer is 1176.5 joule. Okay, so this will be the so from here you can get the QH value. But in the question they asked the value of work done. Work does this engine do every cycle? So for finding work done, we need the QH value. So for that will be using W is equal to E divided by efficiency times QH. Okay, so now we got the value of QH here. So 15 divided by 100 times QH value is 1176.5. So once you multiply it, you will get the answer for this, that is will be 176.5 joule. I'll explain the question once again. So it is a 15% efficient heat engine losses 1000 joules of heat to surrounding per engine cycle. How much work does the engine do every cycle? So for finding work, we have to get the value of QH. QH is the heat transfer into the system. So for finding we need the value of QH, work done, we will need the value of QH, and here in the problem it's given that heat transfer out of the engine. So heat loss only it's given. So we have to find heat transferred into the system from that heat loss value. Then from there you have to calculate the work done. So there will be two steps. In the first step, whatever we written, all the whatever the value is given and what we want to find. In the second step, what we did, we have to find the value of QH, that is heat transferred into the system, that you can get the formula by QC divided by 1 minus efficiency in the terms of percentage. So here 1 minus E divided by 1000, I mean 100, then substitute the value of QC and efficiency, then you will get the answer 1.176.5 joule. Now you got the value of QH. What you have to do, you have to convert, means get the value of work done from that QH value. The formula will be efficiency time QH. It will be 15 divided by 100 times 1176.5. You will get the answer 176.5 joule. Okay. Now we will go to the next problem. Next problem is similar to this kind. Here also we have to solve same way. So a 15% efficient heat engine takes into 500 joules of heat every cycle. Okay. How much work is done by engine during one cycle? So that is the question here. So So here also efficiency is given, that is 15%. You can write it 50 by 100. Okay. Now what is given? Heat engine takes. So here QH value is given. QH is how much? 500 joule is given. Okay. QH is the heat transfer into the engine. So here it is the into the engine. And out of the engine it is QC. So here we no need to do QC, because for finding work done we need only QH value. So for that work done we can write it as E divided by 100 times QH, like same as the earlier problem. Then we have to just substitute the value here. It will be 50 divided by 100 times QH value is given 500. So here answer is very easy. To 50 joule you will get it. So this question I will explain once again quickly. So a 50% efficient heat engine takes in 500 joules of heat every cycle. How much work is done by the engine during one cycle? So here questions the efficiency is given and the value of heat that is into the engine, like heat engine takes value of 500 joules. So energy is also given 500 joules heat amount. Now we have to find the work is done by the engine during one cycle. So for finding that we have to do work done. The formula it will be E divided by 100 times QH. Just substitute the value of efficiency and QH. QH is the heat into the engine. So substitute the value 50 divided by 100 times 500. It will be 250 joule. So this will be the third question. The question is, if heat absorbed by the engine Q1 is equal to 10,000 joule, what is the work done by the Carnot engine? So here we are dealing with Carnot engine and heat absorbed by the system in out absorbed by the engine is given. Okay, so we have to find the work, and from the figure only we have to sort it out. So here the temperature is given, Carnot cycle is given here actually in the for. So in that Q1 is the heat absorbing and Q2 is the heat emitting by the system, and the temperature at the first case T1 it is 800 Kelvin and T2 is 400 Kelvin. So the problem here also here actually temperature already given in the Kelvin, so we no need to convert into any other systems. Like normally if it is in degree Celsius, what we are doing, we are used to do, we used to convert it into the Kelvin and solving problem, right? So here what we have to do, we have to just take this temperature. Now for doing work, and we have to first let us write the information whatever given here. So first one is low temperature, that is T2. It is given already. T2 is 400 Kelvin. Now the high temperature, which is T1, it's also given 800 Kelvin. Okay, now heat input also given, right? Heat input that we can write as Q1. It is given as 10,000 joule. Now we have to find the work done. How much? So for this we know already last class we discussed the efficiency formula by temperature. It will be for a Carnot engine it will be T1 divided minus T2 divided by T1. Okay, so it will be 800 minus 400 divided by 800. That you can get the answer 400 divided by 800. The answer will for the efficiency it will be 0.5 means 1 over 2. Now if you see work was done by the Carnot engine, it will be, how you can write it as W is equal to E times Q1. Now just substitute the value and find the answer, how much joule it will be. answer will be very simple. It will be 1/2 times Q1. It's already given 10,000. Its answer will be 5,000 joule. So the question I'll repeat again. If heat absorbed by the engine Q1, that is equal to 10,000 joule, and what is the work done by the Carnot engine? So from the figure we have to analyze the remaining part. So from here Carnot engine cycle is given. From the cycle we can see that Q1 is the heat transferring into the system and Q2 is the heat coming out of the system, and the temperature difference is 800 Kelvin and 400 Kelvin. Okay. Now we have to solve the problem for what is the work done. So here low temperature is given T2 is equal to 400 Kelvin and high temperature T1 is 800 Kelvin. Now what is the heat input? Heat input is 1000 joule, 10,000 joule. Now we have to find the work. For finding work done, first we have to know the efficiency of the system, that is T1 minus T2 divided by T1. So here already given what is T1, T2. So just substitute those values. So 800 minus 400 divided by 800, it will be half, means 0.5. So efficiency of the system, like E is given as half. Now what you have to do, work was done by the system. It will be system by the Carnot engine. It will be WE times Q1. The half times 10,000. It will be 5,000 joule. So that will be the work done by the Carnot engine. Okay, now we will go to the next problem. So, based on the graph below, the heat engine's temperature is 600 Kelvin and low temperature is 400 Kelvin. If the work done by the engine is W, what is the heat output? Okay, so here Carnot cycle is given, heat engine is given in the two temperature difference, that is T1 and T2, that is 600 Kelvin and 400 Kelvin. From the figure we can clearly understand. So heat transfer into the system is Q1 and W work is done into this in the system, and Q2 is the heat coming out. Okay, now we have to tabulate what are the things given first. So low temperature, that we can write it as T1 or T2 or TL also, so 400 Kelvin, and high temperature TH, that we can write it as 600 Kelvin. Now we need heat output, so we need Q2 value. What will be the Q2? So for that, first we have to go through with efficiency part. So efficiency of the Carnot engine will be TH minus TL divided by TH. So it will be 600 minus 400 divided by 600. So first you find the answer for this. Then we will go to the heat output part. So here you get the answer. It is 1/3. Okay. Now the question is you have to find if the work done by energy is W and what is the heat output, right? So for that we have to go to what will the work done equation, it will be efficiency times Q1. Okay, so Q1 is the heat input. So here efficiency is given 1/3 and Q1 is the heat input. From that you can write it as 3W is equal to Q1. Okay, now what will be the heat output value that only asked in the question. So for finding heat output, that you can write it as Q2. It will be what? Q1 minus work. That we know from the already from the Carnot engine. So it will be Q2 is equal to Q1 is how much? 3W minus W. It will be 2W. So this will be the answer. If work is W, that heat output will be 3W. Heat input will be 3W and heat output will be 2W. So in this question, based on the graph below, engine's temperature is 600 Kelvin and low temperature is 400 Kelvin. If the work done by the engine is W and what is the heat output? Okay, so in this case, the temperature is given TL, it will be 400 Kelvin and TH is given 600 Kelvin. We have to find heat output, that is Q2 value. Now for that first we will find the efficiency E, it will be TH minus TL divided by TH. It will be 600 minus 400 divided by 600. The answer will be 1/3. Okay, now we need to find, the question is clearly given that if the work done by the system is W, so work done we are notating as W, then what will be the heat output? So the work done will be W is equal to EQ1, it will be 1/3 times Q1, that you can write it as 3W is equal to Q1. So what will the heat output? Heat output will be Q2. So Q2 from normal Carnot cycle we know that work done will be Q1 minus Q2. So you can write as Q2 is equal to Q1 minus W. It will be Q2 means Q, substitute the value of Q1 here, 3W minus W. It will be 2W. That will be the work done answer here. Now let us go to the next question. A Carnot engine absorbs heat at temperature 800 Kelvin and efficiency of the Carnot engine is 50%. What is the heat high temperature to increase efficiency to 80% if the low temperature kept constant? Okay, so this question is somewhat different from whatever we solved earlier. So for that, what are the known data? First we will go through that. So high temperature TH, it is given that 800 Kelvin and efficiency E, it is given that 50%, it means 0.5. Okay, now here we want to find high temperature efficiency. temperature, that is TH, when the condition is if efficiency E will be in the 80 percentage, which means 0.8. Okay, so this is the question we are facing now. For that, first we have to find, we know the formula of efficiency. It will be TH minus TL divided by TH. So that we already know. Now from the known information, what we will get it? Efficiency is 0.5, that is equal to 800 temperature. And low temperature we don't know, we keep it as TL divided by high temperature we again know 800. So you can write it as 800 times 0.5 will be 800 minus TL, and solve it for TL. You will get the value of TL here. So here it will be 400 equal to so from the first condition we got the low temperature value. So low temperature value will be 400 Kelvin. Yeah. Um, yeah, the answer in the chat box is correct. So we will solve it fastly then. So we have to find the temperature for high temperature when the efficiency will be 80 percentage, right? So for that we know E is equal to, efficiency is equal to TH minus TL divided by TH. So substitute the value, it will be 0.8, and high temperature we don't know, we can keep it as TH minus low temperature is constant, which is given in the question. So it will be so your answer will be 2000 Kelvin. So this also one different question. But when normally they will ask what is the heat transfer, or how much heat into the system we have to find. Some cases we have to find the efficiency. Some cases we have to find the work done in the system by the system, like it is the Carnot engine, heat engine, whatever. Now in this question it's some different question, like efficiency is given and the temperature is given, what will be the, if efficiency increases, what will be the temperature? It may be the low temperature, it may be the high temperature, what it will be. So this is a one different kind of question you can see actually in this area, this topic. So this will be the next question. It's also similar question actually. First you try, then answer you put it in the chat box, then we will solve the question. So I'll explain these questions. So here the high temperature TH is given. So that is 600 Kelvin. Okay. Now efficiency is given that we can write it as 40%. It will be 0.4. Now we have to find high temperature, that is TH, and efficiency E. It will be 75%. If efficiency is 75%, what will be the high temperature? Okay, so this we can write as 0.75. Now we have to find the solution. So to find the TH first, we will find TL value. So efficiency we can write as it will be TH minus TL divided by TH. So that will be 0.4 equal to. So here what we are doing, we are substituting the value TH in the when the efficiency is 0.4. So it will be 0.4 is equal to 600 minus TL divided by 600. Then just rearrange it and you will get the answer for TL. It will be 360. Now for that high temperature T, so from that value we have to find the high temperature. If the efficiency is 75%, we can write 0.75. That you can write as E is equal to.
Hello.
Yeah.
Yes, I think Mr. Jitin Pal Singh has raised his hand. He wants to ask something.
No, no, ma'am. I got the answer 2400.
Okay, okay,
Okay,
okay.
okay, fine.
So Ashwara, please confirm that he has got the answer.
Yeah. So it will be. So the answer will be 1440. I think mm, here Sanju and Deepak, they both got the correct answer, I think. from the chat box. So this I will explain once again. The question is, a Carnot engine work at high temperature 600 Kelvin with the efficiency 40%. If the efficiency of the engine is 75% and the low temperature kept constant, what is the high temperature? So this is the question. So in the question it is given that the high temperature is 600 Kelvin and here efficiency is 40%, that you can write it as 0.4, and you have to find the high temperature when the efficiency becomes 75%, that is 0.75. Okay, so you know general formula for efficiency, that will be Fe is equal to Th minus TL divided by Th. So you can write it as, substitute the values which already given in the first case, it will be 0.4 and that is equal to 600 minus TL divided by 600. So it will be 0.4 times 600, that is equal to 600 minus TL. Then you can get the value of low temperature from the first case, it will be 600 minus 240, 360 will be the 360 Kelvin will be the low temperature. And the second case in the question, it is the efficiency becomes 75% and low temperature kept constant, then what will be the high temperature? So here the case will come. So high temperature you have to find, efficiency is 75% and low temperature it's same as whatever you got earlier, plus 360 Kelvin. Now you have to use the same formula, efficiency is equal to Th minus TL divided by Th and substitute the value carefully. So it will be 0.75 is equal to Th minus 360 divided by Th. So that you can rewrite it as a 0.75 Th is equal to Th minus 360. So 360 is equal to 0.25 Th. From there you will get the value of high temperature, that is Th is equal to 360 divided by 0.25. We will get the value 1440 Kelvin. And this is also one different question you are going to face in the Carnot engine or heat engine part. Now, um, next is one theory question. And this also you can see in week 3 assignment, I think. So the question is identify the advantage of reheat cycle in steam power plant. Okay, so the options are quality of exit steam is power is lower and quality of exit steam is higher and more pump work and more work output. Okay, so first we have to know what reheat cycle will do in steam power plant. Okay, so what will happen in a reheat cycle? The expansion take place in two turbines actually. So the steam expand into the high pressure turbine to some intermediate pressure and then passes back into the boiler. Then where it is reheated at the constant pressure to a temperature that is usually equal to the original superheat temperature. So that is happening by the reheat cycle. And after why we are advantage of reheat cycle again in the steam power plant. So we are reheating the system means the quality of the excess steam is higher, means it will be more temperature one, and one more thing, more output, more work output will be there. So those two are the answer for this question. So answers are
Ma'am, this quality of exit steam after the turbine or before the turbine?
after turbine, like the total system steam exit of the
So after the turbine, it will go to the condenser. What is the use?
what
Yeah, means after the turbine, work will be done on the turbine, not on the condenser. So what is the relevancy of this quality of exit steam is higher? Because that is a after the turbine only condensation is required. There is no relevance that quality of exit stream is higher.
no like
How does it advantage of a power plant? It should be before the turbine, ma'am. No?
yeah, it's like the expansion, it is taking place inside the turbine, right? But the steam expand in the high pressure in the turbine. In the intermediate stage, it's going back to that boiler. Okay, means going back to the system. From there, we are getting the output, right?
Output from turbine, ma'am. No, not from boiler.
Huh? No, the output will get from the steam power plant, right?
Then okay, ma'am. If it is a power plant, then okay, no problem.
Yeah.
Correct, ma'am.
That turbines are used only in the reheat cycle. Then the amount of the steam will go again to the power plant. From there only we are getting the output. It's an intermediate process. So that's why answer will be B and D. Now this question you do as a assignment. Okay, like try to solve it. We will continue this question in next class. The question is a cyclic heat engine operate between the source temperature 800 degrees Celsius and sink temperature 30 degrees Celsius. What is the least rate of heat rejection per kilowatt net output of the engine? So it's also different kind of question that you try to find it first, and we will solve this in the next class. Just note down this question. I hope uh, everyone note down this question. Like source temperature is 800 degrees Celsius and sink temperature is 30 degrees Celsius. Okay, so we will wind up class here. So this question try to answer, and the next class first question will be this one, and we will continue. And I think this will be the last question from Carnot cycle. Like till week 3, the Carnot cycle engine problems are there. Then next set we will solve the remaining uh, theory part and all. Okay, so we'll stop here. We'll meet in the next class.